In calculus, there are two main concepts: derivatives and integrals. Derivatives will typically be written like d by dx. Integrals will be like this: f of x dx. We would be differentiating a function. For now, let's just focus on derivatives. Derivatives and integrals are basically inverse functions of each other. By the fundamental theorem of calculus, they kind of undo each other. If you take the derivative of an integral, you end up with the function. If you integrate the derivative, you get the function back. They're just basically inverse operators in a way. Derivatives are basically, if you have a function, let's say we have like x squared, the derivative would be the instantaneous rate of change. So if we have a point, let's say we go right there, usually in textbooks you'll say, oh, well, we'll do the secant line from this point to that point, and imagine it only goes through those 2 points. That's what like the secant line would be. As we get closer and closer, we bring these 2 points closer and closer together, we get what's called the tangent point, and it goes through only 1 point, and it would look something like that. The integral would be the like opposite of this. If we had like, x squared, and let's say we go from 0 to, let's say, like 1, the integral would be this area under the curve, this area right there. But for now, let's just focus on derivatives. So derivatives is the slope of this tangent line. That's basically what it is. The derivative follows the limit definition. F prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. Now, this looks a little scary, but it's not so bad. Basically, if we have a function of x, this will equal something, let's say 2x. Wherever there's an x, we replace that with an x plus h. So 2x plus h would be 2x plus 2h. So then we do the limit, we can do the limit definition of x. 2x plus 2h minus 2x over h, and the 2x's cancel, so we're just left with 2h over h, which is just equal to 2, and that would be the slope of the tangent line for our 2x function. That's an arrow. If our function doesn't contain an x, if, say, f of x is equal to c, then we're just left with the limit as h approaches 0 of c minus c all over h, which is just 0, which is the derivative of the constant. If now we say, okay, well, our function is now x squared, we would have to do x plus h quantity squared, which would be x squared plus 2xh plus h squared, and then using the limit definition, and this comes out pretty nicely. You can cancel out the x squareds, And then we have the limit as h approaches 0 of 2xh plus h squared over h. We can divide out the h, and we're left with the limit as h approaches 0 of 2x plus h, but h goes to 0, so it's just 2x. Now, these are just the basics of finding the derivative, but we can also find the slope of the tangent line. If we want to find the slope of the tangent line at x is equal to 2, we just plug 2 into the derivative of x, which would be 2 times 2, and that would be equal to 4. We can now find the line through the point 2, 4, because we have y is equal to x squared, and we say x is equal to 2, so y must equal to 4. So to find the slope, or to find the line through the point, y minus y1 is equal to m times x minus x1, which would be y minus 4 equal to 4 times x minus 2, or y is equal to 4x plus, minus 4, or y is equal to 4 times x minus 1. Could write it like that. Graphing these on Desmos will lead to something like this, where we have our parabola, and we're looking at the point 2, 4. So like around right there, we'll have another line that will go through just like that, and it'll be really close to that parabola. And that's about it for this video. In the next video, I'll go over the basic rules of finding the derivative.